Yeah, so hi, my name is Kristine Chen. I'm an SRE at the Google San Francisco office. I manage a team that focuses on client-side reliability, so applying SRE principles and a production mindset to the mobile world. I've been at Google for a little over 4.5 years now. I spent a little over a year and a half in this area, and before that I was on Search SRE and supported the serving infrastructure for Google Search. So I do have a little bit of experience on the server side of things as well, and I've tried to take what I learned on the server side and applied it to the mobile world. So today I'd like to share with you some of our learnings, my team's learnings in this area. So first, a little bit about the current state of SRE. We've had years of experience working on improving the code running on our own servers. So we at Google, we wrote a book about site reliability engineering. You may have heard of it, I hope. And it contains just about everything we've learned so far. This is a quote I pulled from the SRE book that I think is a pretty good summary of SRE as we know it. So Ben Traynor, one of the VPs of engineering at Google, and also the person who we say coined the term SRE, said that in general, an SRE team is responsible for availability, latency, performance, efficiency, change management, monitoring, emergency response, and capacity planning. So that's all great and all. So how does this apply to mobile? Well, first, why mobile? More users access the internet through mobile devices than ever before. Our next wave of users are in a market where mobile is the primary way to access the internet. For Google Search, mobile search traffic has surpassed desktop traffic globally, and there are trillions of searches on Google, and over half of these are mobile searches. So, okay, hopefully you can think now like mobile matters at least a little bit. So what can we use from what we've learned about managing server-side systems? Before I go into that, we should frame the environment in which we're working. In a way, the mobile world, you can think of it as a distributed system that has billions of machines, an order of magnitude larger than what the larger companies are used to for their servers. We have code running on people's devices that people interact with almost daily, and yet we have a limited set of data to make decisions off of, simply due to the restrictions of the mobile environment. So first, before I go any further, one caveat. Much of this talk is primarily based on Android. They're based on my experience with the Android ecosystem. But many of these points aren't really truly Android specific and could very well apply to other platforms. Google applications, they run on iOS as well, and they actually run very well. And applying the same kind of production mindset to iOS applications is still important to us. So first, the first challenge. The mobile environment is non-uniform and uncontrollable. Perhaps the most obvious challenge is that we don't actually have control over a user's device. Take the server world, for instance. To get a simple change to production, we'll deploy it to some canary cells, and when it looks good, we'll push it directly to production. At the end of the day, all machines in all data centers will be running the same version. This sounds easy enough, right? But this is not true in mobile. We don't have that same level of control over an application on a user's mobile device. A user can say, no, I do not want this upgrade. A user may not actually have the necessary data or space on their device to actually upgrade the application to the newest version. So you end up with a variety of application versions running in the wild. Similarly, a user's device may not be on the latest operating system version, nor the latest hardware. And this adds multiple dimensions to your production environment and can make your debugging much more complicated. You might get an alert sometime that says this old binary running on this obscure version of the OS is suddenly failing. Well, what caused that to start failing? So it presents some different challenges. The next challenge, there are many options for application monitoring, but no option is perfect. With a good monitoring system, you can get signals back within seconds of a change on a server. You can actually conduct some monitoring of your client code from the server side. This mostly works if your application talks to one of your servers. So you can use the request and response logs to make educated assumptions about how your application is behaving. However, not all client-side issues can be caught through this kind of monitoring. Everything we monitor is constrained by our privacy policies, of course, and even then, most of the user data is not of production use for us. If your code has a bug in it that crashes the application when a user uses it, you won't necessarily get that information. And client-side monitoring is necessarily restricted by the user's data plan and device's battery life, as well as privacy concerns. You wouldn't want to send an event you wouldn't want to send an event on the device back to your servers every single time something happened, or you risk burning the battery or the user's data, or even worse, the user's trust. You have to be careful in what you monitor and how you monitor it. And of course, this is all a moot point if the user just decides to opt out of sending the data back at all. So, which they can do. There is a checkbox. So the next challenge, effecting change is hard. When a release goes out to your servers and creates havoc, there's usually the option to roll back the release. But when a release goes out to a mobile device and causes issues, what do? There's no rollback support for either Android or iOS. In that case, the developer has to build a new version and push it out to production again, and hope that users accept the update. But as we know from earlier, not all users will move to the newest version. And hope is not a strategy here. So instead, the release process becomes lengthy and complicated in an effort to catch all issues before they hit public devices. There are ways around this, which I will go into a little bit later, but in the end, it does come down to catching more issues earlier in the application development lifecycle. So now that I've framed the current state, I'd like to talk about the different areas where SRE can make sense in mobile. So this is a quote that was just up a few slides ago, so I took Ben Trainer's quote and modified it a bit to fit the mobile world. So in general, an SRE team for mobile is responsible for availability, latency, performance, efficiency, change management, monitoring, and emergency response. You notice that most of this is the same as the original tenets for SRE, except for the part about capacity planning, which I don't think quite makes sense in this area. But for the rest of this talk, I will focus on some of these areas. And I chose, well, those are the areas in bold, actually. And I chose those areas because I think these are the basics that we should build off of when tackling a new environment like mobile. So first, monitoring. Monitoring is crucial to running a stable application. Much like in the server world, in order to make any rational business changes or measure the application's success, you need to set up some kind of monitoring. You can monitor the application from the perspective of the server, which called server-side monitoring. And this only really works, again, as if your application talks to your servers. For example, the server can note how many requests it's receiving from the application and how many successful responses it's able to send back. This monitoring can be useful, but it's not comprehensive. You wouldn't be able to tell if the application was able to do the correct thing with the response with just server-side monitoring. For example, the server could have successfully created a response and sent it out back to the client, but that response could have ended up being a response of death or caused debugging to the client, and in the end causes the client to crash loop. You can't detect that with just server-side monitoring. So client-side monitoring is monitoring what happens on the device itself. I like to stress again here that everything we monitor is constrained by our privacy policies. But one way to do client-side monitoring is with logs. An event can be logged when something happens in the application. And at some point, the logs are batched up and sent back to the servers for processing. The reason why the logs aren't sent back right when they're logged, actually, is just because, again, you don't want to send an event back every single time something happened. Otherwise, you can burn the user's battery very quickly. After the logs are sent to your servers, they can then be processed into a format that is sent on to whatever monitoring system you use for normal server-side monitoring. Note that this means that your metrics will not come back in a matter of seconds or milliseconds, but rather on the order of minutes to hours. Black box monitoring can also be used, where a probe is used to probe application behavior on a test device or emulator and reports back success or failure. This can help you see if any server-side changes besides binary releases affected your application's behavior. For example, if a config change could result in your server sending the client a response that it can't use. So monitoring can help you find out when something is wrong, but you won't know what actions you need until you actually experience an outage. Until then, some things are, at best, guesses of what we think we might need. For example, I'll kind of keep going back to this because it is a very obvious example, but a change happens on the server side that changes the response when the application can't handle well. But this is actually the best case scenario, since the fix is simple. You just roll back the change on the server. And this is much more within our control. The more difficult situation comes when application code itself is broken. So how do you fix it? If you're lucky enough to have the code path guarded by a flag, you can flip the flag and disable the code path. You want to make sure that your application can get the flag updates even when it's misbehaving. So if your client if it's a really bad bug and your client ends up crash looping and actually can't receive the flag updates, that's going to be a bigger issue. The most important thing is to learn from the postmortems. As we're still in a relatively new area where the tools and automation are still largely under development, postmortems are incredibly useful to learn what to do next. So write good postmortems with action items that you can iterate on. Reliable release processes remain important in the mobile world and perhaps even more important than before since changes are harder to make once something is out on public devices. Our usual means of release automation don't quite apply here since you can't exactly drain a phone to canary the next release. You can try to exhaustively test your code in a device lab or on emulators, but in the end, it's not feasible to test all possible scenarios for your code in all possible environments. Because as I mentioned, you have a variety of OS versions, a variety of application versions, a variety of device versions, et cetera, et cetera. So you also can't strictly compare the new version to the old version while you're upgrading to the new version because the early adopters are usually those on better devices with better connectivity. Latency is one of those metrics which may look great in the first few days because you're getting all those users that have great devices on great networks. But then you look a week later and latency sucks once the long tail of users on lower end devices and worse networks start updating. Another thing to account for is the time it takes for your users to update. Just because you pushed your application to 100% in the Play Store or the App Store doesn't mean that 100% of users immediately update. Updates depend on user preferences, so your applications may update at any time, regardless of network, or they may wait for the user to click yes on the update pending dialog. So a common way to do application rollouts in Android is to conduct staged rollouts. In a staged rollout, you release to a percentage of users, which you can increase over time. So next, I'll talk a little bit about these stages that some applications can use for their rollouts. The first stage, alpha, consists of the development team. And it's the safest stage since you don't affect external users. It's also the most unreliable stage since developers also tend to own a uniform group of higher-end devices. You can catch large critical bugs in this stage, but due to the poor diversity of both devices and environments, you're unlikely to catch most issues. The next stage is the beta stage, and with beta, you expand your original group to include internal users beyond just the application developers. You can even expand your beta population to opted-in public users. However, and I am making a broad generalization here, this tends to have selection bias, since people who opt into beta programs are usually people who are more enthusiastic about the application, may have better devices, may have better connectivity, etc. After the beta stage, you reach the third stage, or canary. And during canary, you can ramp up to a small number of the public population. But what is this small number? You want to make sure that there's a large enough population to get good data from, but you also want to make sure you're not affecting more users than necessary. You can decide the right population size based off the confidence interval you're comfortable with. And finally, after the canary is successful, we can push to all users. Again, not all users will upgrade, so you won't be able to move all users to the newest version. However, you'll probably be able to move most of them. It does take time to advance through each stage, and overall, the release process usually takes multiple weeks to release to users. The release timing depends on how quickly users upgrade and how long it takes to receive data back on the release. We've had releases take 6 to 8 weeks, and we were able to bring them down to 3 weeks. And more improvements can be made, though. The reason why we want to keep bringing these down is because the longer you have your release cycles, the more changes can be bundled up in one release, and when something does go really bad, it's really hard to figure out what change actually caused the issue. So we do want to improve the velocity of our releases. So other changes. Changes can happen in other ways than just an application rollout. Both experiments and features need to be launched carefully in a similar fashion, and both should be disabled by default in the new application code and enabled by on the server side. This has the added benefit of moving control to the server side in case something does go wrong. But neither an experiment nor a feature should be released directly to the public without sufficient canarying. And one way to canary an experiment or feature is to conduct tests with experiment and control populations while you're ramping up in production. So we're still far from the mature environment we're familiar with in the server-side world. Tools and automation aren't quite there yet, and it's kind of like the Wild West out there because developers also don't quite know what they want either. So what does the future look like if we're successful? Well, if we can get to a state where all of these above on the slide are true in the next few years, I'd actually call this a success. So we should get to a point where our canaries provide us the right data so we have confidence in our releases. This means getting enough data on a correctly sized population and receiving the data in a timely manner so we can move forward to the next stage of the release. Easy experimentation is mostly for the developers, but it comes down to enabling developers to experiment quickly and safely. Provide developers the tools so that they know how their features perform on real devices. We'd also like to get metrics back as soon as possible to reduce the MTTR. We're still working within the restrictive environment for mobile, so it won't be perfect. It won't be like the server side. But we can strive for something as close to real-time as possible. I think this fourth bullet point is fairly self-explanatory. We need the correct metrics in order to make the useful decisions. And lastly, let's try to move as much change to the server side as possible. If we guard everything behind feature flags and launch behind flags, and ensure that server-side changes don't break the client, this means actually like knowing your full stack, including the client and how the client behaves if something changes on the server. Well, if we do all that, then I think we've done a lot already. Yep, that's it for me. I wanted to leave time for questions so that, because I know this is interesting space, I hope, and I hope people have questions. So please ask questions, and yeah, that's it for me. Thank you.
Hello. You had showed, I think you called it, black box testing, where you have the client always set up to make interactions against the server.
Yeah.
What frameworks or tooling do you use at Google to automate that process? Is it something QA does manually, or do you have some type of emulator framework set up?
Yeah. So I'm going to try to talk, obviously, within the by not talking too much about Google-specific technologies, but it's not manual setup. It is definitely it's like an automated setup. And you probably heard of Firebase and like the Firebase test. Like there's like a Firebase test lab, I believe, which you can test on like real devices and things. So it's something you can think of it like that, where you run it on these devices.
Hi.
Yeah.
When you deploy code to the client, a new application or just a new version of your application, you said one way you monitor the client's healthy is through logs. You process the logs on the server side, make sure everything is okay. If some bad event happened on the client, then it gets reported to the server. A simple solution that a lot of other places use is some kind of heartbeat from the application itself on a periodic interval. Is there a reason you didn't touch upon it? Is it not something that's commonly used in Android applications, or?
So sorry, could you repeat the last part of it?
So the client can heartbeat every so often and say, "Hey, I'm alive."
Yeah.
So why not use something like that to do like an active status check?
Yeah, I think that's actually it's also a good point. Like that's also a useful tool to use. I think that is good to measure your client's date, like kind of like the trend of weekly, daily trends and stuff. But it's not. There's still sometimes when, like, I guess if your application is crashing, for example, you don't want to wait for the heartbeat to know when that happens. You want to know that as soon as you can. So these kind of events, you will probably, like the more important events, you want to know sooner than just like a daily check-in, for example. I mean, I think both are useful, obviously, to understand the health of your client. But yeah.
Right.
Yeah. So you had also mentioned doing slow client rollouts. So I think you'd mentioned one case up to 3 to 6 weeks.
Yeah.
I was curious if you ran into any friction with the product teams on that kind of schedule, or how you're able to come to that kind of agreement.
As in, because any kind of friction, or just?
Well, so a lot of times the product team doesn't want to wait 6 weeks to get their code fully deployed.
Yeah. So yeah, that's a good question. Yes, the product team definitely doesn't want to wait that long to release their code. But the unfortunate reality of client-side development is that it does need to take that long, because you just are not sure what your code's going to do on real life production devices. And it's really more out of safety. They understand that, but they also don't like it. So that's why there is still push to make it faster.
Yeah, I mean, I totally agree as an SRE, so I was just curious how much friction you ran into, if you had to have a lot of debate around this, or if it was...
I think it's accepted, essentially, as a way of life, more or less. So,
okay, thanks.
Yeah.
One more question.
Yeah, sure.
Just curious, you kind of glazed upon the topic, but what happens if you roll out an application update that kind of breaks the device? Your application is not able to download any more new configs or even new software at all. Has something like that happened at a scale in which Google is dealing, and how is Google able to, like at that point you cannot do anything? How do you take care of those situations?
Yeah, that's a good question. I would say we are, I've been working in this space for about a year and a half, which roughly reflects how, so 2 year and a half of experience. I don't think we've solved this problem completely, but I do think that once you get into this state, the best thing you can do right now is mitigate it as soon as possible, and do what you can to release the fixed version to people. And unfortunately, that's not what we're used to with working with server side. We want to fix everything as soon as we can, kind of thing. And you have to still consider the environment that you're working in when we.
But then the client is not able to download the new fix because it's completely broken.
Right. Yeah. And I don't quite have a solution for you there. It is definitely a real problem, but I don't have a solution for you there.
All right.
Yep. Okay. Any more questions? All right. Oh.
Hi. So we're kind of new at this. My company doesn't have a mobile app yet because our development team is really small, our support team is really small, and the biggest holdup, I guess, has been supporting it. On a web app, you can say, go download the latest version of Chrome, but we don't have the capacity to deal with people calling in and saying, oh, well, this box looks funny on this, 6-7-year-old phone that, So whenever you guys are putting together requirements for, rolling out a new mobile app, do you have any kind of processes or conversations you've had to kind of set a baseline as to what kind of devices you'll support and what you won't, what you would communicate to a support team who has to take those phone calls? So you can't support everything, right?
Yes, but I can't answer that question completely, I guess. Yeah. Short answer, yes.
Okay.
Yeah. Any other questions? Yeah.
I was wondering how you deal with, when you're looking at the client, there's a lot of sources of failures that are not in your control. For example, the network between the user and Google.
Yeah. And
how do you deal with those as SRE?
Better instrumentation, essentially. Being able to tell when, instrumenting the app to let you know when these kind of errors actually happen, and classifying these errors as such is one of the ways. Yeah. Cool. Okay, well, thank you very much.